Hello, I'm Kayla Flager, and I am here to talk about the instant ice experiment that we had for Module 8. So this experiment basically involves taking water, pure bottled water, and placing it in the freezer. We let the water slowly cool down, and we're going to try a couple different things with it to allow it to kind of instantly freeze in a couple of different ways. So we're going to go through those today, and I'm going to explain, why those instant freezes are taking place. The experiment was really simple. All we needed was bottled water, or pure bottled water, and a freezer to put them in. And it was really easy to set up. I set the bottles in the freezer, left them in there for about 3 hours and 15 minutes or so. I did try the experiment with putting the water in the freezer for 2 hours and 45 minutes as recommended in the video, but I guess my freezer must not have been as cold because it didn't work. So I left them in there for about 3 hours and 15 minutes before trying these experiments. The first experiment is going to involve taking the bottle of cooled water and giving it some type of impact. So I decided to slam it down on the counter, and I'll show you what happened here. You can see in the video that it does start to solidify quite a bit. Okay. Oops. In the second experiment, we poured the cooled water over ice that was placed in just like a glass container. So you can see what happens here. As you pour the water over the ice, it starts to form little peaks of, kind of slush. So it was really, really cool to see that taking place. I had a lot of fun with this. Okay, you kind of get the idea. And then for the third experiment, we dipped ice into the water. So I poured the water into the glass container, I put a piece of ice in it, and it instantly solidified in the container. So none of my results formed like really solid ice. It was more kind of slushy, and I think that if the water was more cooled, then the results would have been a little bit more dramatic. But nonetheless, it was really cool to kind of see a real life application of, some of the things that we've been learning about. So for the science behind this experiment, basically by placing the water in the freezer, we are allowing it to cool down slowly. So when it's cooling slowly like that, it allows the water to reach a temperature that's below freezing. It's below either 32 degrees Fahrenheit or 0 degrees Celsius in this case, but the water still remains as a liquid, and this is actually called supercooling. So we're allowing the water to supercool in the freezer. It becomes the temperature dips below freezing, but the water still remains in the state that it was when we placed it in, which is its liquid form. So basically, the process of ice crystals beginning to grow, or nucleation, requires some type of impurity or something to kickstart it for that to be able to take place. So we need the ice crystals to either have something to attach to grow on, or something to kind of shock it into forming those ice crystals. In this particular case, the water was too pure for that nucleation to occur on its own. So if the water's so pure, there's nothing for the ice crystals to start to form on inside of the bottles because that water is so pure. So there's no type of impurity in it that would allow the ice crystals to grow. So it was our job to kind of give it some type of kickstart, if you will. In the case of the first experiment that I did, the ice crystals were able to form. Each of the experiments that we performed, we created a chance for those ice crystals to form, and I'm going to explain why. So with the first experiment, which was slamming the bottle onto the counter, the water is very cold, it's below freezing temperature, and when we hit the bottle on the counter, actually a shock wave is sent through the water, through the molecules, and that's what allows the nucleation to occur and the water to rapidly freeze. As you can see, it wasn't really solid ice, but it was a much more solid state than it was when we began with. So sending that shock wave through the molecules allowed them to rearrange themselves and to form into ice crystals instantly. In the case of the second experiment with pouring the water over the ice crystals, basically the ice that's in this cup right here comes straight out of my freezer. It's not pure water. It's, just comes out of the water pipe and turns into ice in the freezer. So it's not pure and it has many impurities. And so when we're able to pour the water onto the ice cubes, there are enough impurities for the ice crystals to form. So even though the water that's getting poured out is pure, it has something to latch onto and it begins to form those ice crystals. As you can see here, it's kind of a slushy material or slushy consistency, but nonetheless, there's enough impurities for the ice crystals to be able to form and build off of one another, and it grows into that slush-like substance. And then in the third and final example that we had here, it's kind of a reverse effect of the second experiment. So instead of pouring the water into the ice, we're putting the ice into the water. I poured the water into this clean glass container. It remained liquid, but when I placed the ice cube in it, you could see it kind of freeze up quite a bit. And so it's the opposite results of what we saw in experiment 2, because we know that that ice is impure. So when we place it in the water, it allows the crystals to grow around it and can solidify the ice in the container. So once again, this experiment was really cool. It was a lot of fun to get to do some of the hands-on kind of things. And I just want to take the opportunity to thank you for everything throughout the course of this class. I've really enjoyed it. I've really learned a lot more than I ever thought I would about chemistry. It's been a lot of information, but I feel like I've gotten a really great takeaway from it. So thank you for your responsiveness and for setting us up to be successful and have a great class. So thank you so much.